You know, every single flight, whether it's a tiny little two-seater or a massive airliner, it all comes down to a really basic principle of physics: weight and balance. If you get it right, the flight is as smooth as can be. But if you get it wrong, well, a perfectly good airplane can become completely uncontrollable.
So, let me ask you this. What do you think is the absolute most critical check a pilot makes before they even think about starting the engines? It's probably not what you'd guess. It has nothing to do with the fuel gauge or the flight controls. It's actually a puzzle that has to be solved on the ground to guarantee safety up in the air.
All right, so in this explainer, we are going to break down that exact puzzle. First, we'll get into the unseen forces at play. Then we'll look at the seriously high cost of being overweight. After that, we're going to dive into the art of finding something called the center of gravity. And finally, we'll see exactly how pilots do the math to make sure every flight is a safe one.
Okay, let's dive right in. At its very core, you can think of any flight as a constant battle. You've got lift, which is pulling the plane up, and you've got weight, which is pulling it down. The pilot's #1 job is to make sure lift always wins that battle. And that whole process starts with getting a handle on the aircraft's weight.
And look, these weight and balance limits, they are not just suggestions. They are absolutely critical for flight safety. If you exceed the maximum weight, you could literally compromise the plane's structure. And if you put that weight in the wrong place, you can make the plane impossible to control no matter how skilled the pilot is.
Let's start with the first piece of this puzzle, the danger of simply being overloaded. Now, it might seem kind of obvious that too heavy is bad, but the consequences go way further than you might think.
See, excessive weight kicks off this whole domino effect of performance problems. You need more speed and a much longer runway just to get off the ground. Your climb is slower, it's shallower. You can't fly as high or as far. And, maybe most critically, your stalling speed goes up, which shrinks that vital safety margin between flying and, well, not flying.
To really make this concrete, think about this number: 6 pounds. That's all 1 gallon of aviation gas weighs. It doesn't sound like a lot, right? But as the source material points out, just 30 gallons of fuel can weigh more than an entire passenger. It's crazy how fast that weight adds up.
So, staying under the weight limit is one thing, but that's really only half the battle. The other half, the much more complex part of the puzzle, is where you put all that weight.
Honestly, the best way to picture this is to think of an airplane like a giant seesaw. You know how it works. If you put too much weight on one end, or even if you just move a little bit of weight too far from the middle, the whole thing gets all wobbly and unstable. For a plane, that little balance point is absolutely everything. Now that balance point has a technical name, the center of gravity, or just CG for short. It's the one theoretical spot where the entire weight of the plane is concentrated. And here's the kicker: it's not a fixed point. Every time a passenger shifts in their seat, or a bag gets loaded, or fuel gets burned off, that CG moves. The manufacturer defines a super specific range, sometimes it's just a few inches, where that CG absolutely must be for the plane to be stable and controllable.
And staying in that range is so critical. If the CG is too far forward, the plane becomes nose-heavy. That makes it tough to get the nose up for takeoff or to land gently. But if it's too far back, that's when things get really dangerous. A tail-heavy plane becomes incredibly unstable. It's very difficult to recover from a stall, and it's shockingly easy to accidentally overstress the aircraft.
So how in the world do pilots solve this incredibly complex puzzle before every single flight? Well, they use a really methodical process that's based on a couple of simple but really powerful principles.
It all starts with two key terms. The first one is called the arm. This is just the distance, usually in inches, from a fixed reference point on the plane, they call it the datum, to any given item. A passenger, a bag, a tank of fuel. Just think of it as that item's specific address on the seesaw. The second term is moment. Now this is where the physics really comes in. It's the turning force, or the leverage that an object creates. You get it by multiplying its weight by its arm. This is so important because it means a really heavy object close to the center can have the exact same impact as a very light object that's way far out. And that brings us to the pilot's golden rule: weights times arm equals moment. This simple little formula is the absolute heart of the entire process. It lets a pilot put a number on the exact effect that every single item has on the airplane's balance. So here's how they put it all together in a step-by-step process. The pilot lists the weight of literally everything on board. They find the arm for each of those items from the plane's manual. Then they calculate the moment for each one.
Finally, they add up all the weights, add up all the moments, and then divide that total moment by the total weight. And that final number, that's the center of gravity.
So here's a quick example of what that looks like in practice. You can see every item listed out. The empty plane, the people in the front, the people in the back, the fuel, they all have their own weight, arm, and the resulting moment. The pilot just adds up the weight column to get 3,320 pounds, adds up the moment column to get 281,430 inch-pounds, divides the moment by the weight, and bam, the final CG is 84.8 inches from the datum.
Now, doing all that math is great, but there's one last step. It's a visual check that makes the whole process more intuitive and helps catch any mistakes. For this, pilots use a special graph provided by the aircraft manufacturer.
This graph is called a center of gravity moment envelope. It's pretty cool. They just take their two big final numbers, that total weight and the total moment, and find the spot where those two values intersect on the chart.
And this right here is the final piece of the puzzle, the moment of truth. If that little point they plotted falls inside the safe envelope on the chart, then the aircraft is officially within its weight and balance limits. It's a simple, clear, visual confirmation that gives the pilot the green light for a safe flight.
So, you see, every flight has to begin with this critical act of balance. A pilot has to balance their plane perfectly for a safe flight. Which kind of makes you think, what are you balancing for a successful journey?